Okay, here are two examples using the chain rule. One is just a basic example actually using the chain rule, and the next one is a example of using the chain rule within using another rule, which happens to be the product rule. So let's take a look at this example here. First of all, let's talk about, you spent some time in pre-calculus talking about composition of functions. So in other words, like if I had a function f of x equals x to the 1/2, right? Then f of 2 would be equal to 2 to the 1/2. F of 3 would be equal to 3 to the 1/2. Well, now I'm going to take f of this function. So I have actually replacing the variable x with another function. That is a composition, and that would be the inner function. The outer function would be, again, x to the 1/2. Inner function is this polynomial 3x squared minus 5x. So one of the ways you could do this is look at the chain rule in this theorem. It's basically the derivative of a function y with respect to x is you take the derivative of y, the outer function, okay, y is just the function of u, and then multiply it by the derivative of the inner function with respect to x. So we're taking the derivative of the function y with respect to u. We're just defining a new function u here. And then we're multiplying by the derivative of the inner function with respect to x. So there we have it right here. If we take the derivative of y with respect to u, we just get, again, the 1/2 and then subtract 1 from there. You get u to the negative 1/2. Take the derivative of u with respect to x, we just take 2 times 3 and get 6x, and then we have the minus 5, and then we simplify from that point on by substituting back in for u this expression. So the next step would just be to replace the u with that, and we still have the 6x minus 5 here. And then if we do anything else to simplify that, which we can, we're just going to write this as a positive exponent in the denominator, and this again would just be in the numerator. All right. I like using, that's one way some people prefer that. I would rather actually use this technique over here on this next page. I can get my page to turn here, which if I look at my outer function and my inner function, I'm going to take the derivative of the outer, evaluate it at the inner times the derivative of the inner, and just kind of write it out like this. So you'll see I end up with the same thing as what I do over here, except I don't make that introduce a third variable here, u. So if I look at this as the inner function, this is the way I like to do it. And the outer function is, again, x to the 1/2. I take 1/2 here, subtract 1, I get negative 1/2, right? 1/2 minus 1, or 2/2 is negative 1/2. So I write this without this filled in. I put that in blue, and then I fill in the parentheses where the x would be with the inner function, which is this polynomial. Then I'm going to multiply by this, the derivative of this inner function here, which is, again, is just 6x minus 5. So I'm kind of using this technique here. It's just a different way of looking at it, different notation. And again, all I need to do is simplify that. I'm going to write this as a positive 1/2 power, and then I'll write it, instead of 1/2 power, I'll write the square root of x. Here I just write this as 6x minus 5 over 1, and then I multiply straight across. And that's about as simple as I can get this thing. 1 times 6x minus 5 is just that, and then 1 times this thing, I get the same thing down here. All right, so let's take a look at number 2. Now, number 2 poses a problem because if I cover this up, that's my composition function, right? X to the 5th is my outer, and I should say t to the 5th, right? And then my inner is 3t to the 6th minus 1. But now I'm also multiplying it by another function. So I'm going to have to use the product rule. But then whenever I take the derivative of the second function here, I'm going to have to use the chain rule on it. So we're kind of using rules within rules here, so to speak. Now, before you get really frustrated, remember, this is going to take a little bit of time to work through this stuff. And it's almost like you got to train your eyes how to look at it, or train your brain how to look at it. So let's look at it from the big picture here. I'm taking my first, right, times the derivative of the second, which is this. I'll explain how I get the derivative here, okay? Plus, I just put this on a line to distinguish this a little bit easier. Okay, this is really all one line. I just kind of separated it, so I just put the plus sign here. Plus the second times the derivative of the first, okay? So that derivative is easy, right? Because that's just a linear function. So I just take the coefficient. So there's my second times the derivative of the first. But how did I get the derivative of the second here when I took the first times the derivative of the second? Well, that's when I used the chain rule. I took the 5 down front here. Okay. I then go ahead and I evaluate, take the 5 down front, so excuse me, subtract 1 here, and then I multiply by the inner function here, which is 6 times 3 is 18, and subtract 1, I get t to the 5th. Okay, so now I'm just going to rewrite this thing, simplifying. I just wrote the -2 out front here. I took all this stuff and multiplied it. 18, I have really 1, 2, 3, 4, 5, 6 things. So I'm going to just kind of leave this over here, this 3t to the 6th to the 4th. Then I'm going to multiply the other 4 things here, or 5 things. 18 times t to the 5th times 5 times t times -2. I can do that in any order. So let's multiply all the numbers first. 5 times 2 is 10. Times 18, I get 180. T times t to the 5th gives me t to the 6th. And of course, I have a negative there. Okay, I have negative times all those positives will give me a negative product. So I end up with, when I multiply all this together, I end up with this expression here. Okay, so you can see the calculus is done in one step, and then again, we're wrestling with algebra and the steps beyond. Now, here's, sometimes these answers, you could probably just type this in. You may even be able to type this in, but notice you got all these parentheses to worry about. And this really probably wouldn't be too bad to type in. But just know that if you do some examples, they're going to do some of this and just simplifying and factoring out common factors. Okay. So what factors would be common to both of these terms? I have one term right here and one term right here. Well, a negative or a 2 is a -2 can be factored out. So I'm going to factor out the -2. And also I have common factor of 3t to the 6 minus 1. I have 4 of those factors here, and here I have 5. Well, I'm going to take out the lowest common multiple of those, or lowest common factor of those, which would be, I should say the lowest common power, which would be this thing to the 4th power. So I'm going to factor out the -2 and 4 of these. That comes out. Put a big set of brackets. So if I took the -2 out from here, I'm left with 90. And then I took out 4 of these things, right? So I took out the 2, so I'm left with 90. So, and this is gone. So I'm really just left with 90t to the 6. So notice, again, if I use the distributive property and I multiply this times this, I'm just going to get this back. So all I did was factor that out. I took out 4 of these factors, so I left behind 1, and the -2 was gone as well, excuse me. So then I'm just left with a +1 here. So now I just have this expression right here, okay, multiplied by this expression. So now notice I have, if I distribute a 1, I'm still going to get this, 3t to the 6 minus 1. I have like terms here, so I take 90 of these t to the 6 plus another 3, and I get 93t to the 6 minus 1. And then I just, instead of using brackets, I just use parentheses here, okay? So, going from this big thing right here to this was just a matter of using algebra, okay? Combining like terms, multiplying, monomials, and, finally factoring those, all right? So that's where a lot of that work comes in. Okay, so there you have it, the chain rule, and also, by itself, and then also the chain rule within the product rule. Okay, so now you're going to have rules of different derivatives used within rules. You wouldn't even want to dare think about, taking, going back with the definition of a limit here with this thing. It would just be really, really difficult. Not impossible, but very difficult to do. And I know that doesn't appear to be easy as well. Okay, well, we will see you next video. We're going to start talking about derivatives of exponential functions and log functions.